Hello.
Hello.
Hi.
Hello, sir.
We'll just wait for Dave to join.
Yeah.
Start off with a couple of questions.
Yeah. So just one more thing. Actually, I'm writing the IOQM this year, like the PRMO. So if you have any sample questions or papers, can you like send it?
Okay. Sample questions. You have the Allen material.
No, Alan didn't give material for this. They only gave some material for KVP. I'm solving that as well, but I don't think that is. I don't know if it's sufficient or not.
Okay, I'll send you some stuff. Allen material is there that I have for IOQM.
Oh,
So
okay.
I'll find out and send.
Yeah. Okay. Thank you.
Uh, so question is, there are 12 points in a plane, five of which are concyclic, and out of the remaining 7 points, no three are collinear and none concyclic with the previous 5 points. Find the number of circles. Find the number of circles passing through passing through at least 3 points out of the given 12 points. Basically, there are 12 points in a plane, 5 of which are concyclic. So 5 points lie on one circle. Out of the remaining 7 points, no 3 are collinear and none concyclic with the previous 5 points. Find the number of circles passing through at least 3 points out of the given 12 points. Okay, so first question, are you guys thinking?
Yes, sir, I'm trying.
So basically, there are many points in the plane, five of which are concyclic. That means there is a circle and 5 points are there, right? Seven
Yeah.
remaining points are such that no three are collinear. Seven remaining points are there, but they are not on the same line. No three of them are collinear,
Yeah,
and none are concyclic with the previous 5 points. So they are also not lying on the previous 5 point circle. Like these seven are not on the circle or not.
hmm,
Yeah.
You have to find the total number of circles passing through at least three out of the given 12 points. When you have a circle, how many points do you need to define a circle?
3.
Yeah, so you need 3 points to define a circle because there are three constants here. If you
Yep,
have three constants, you'll get three equations from which you can find G, F, and C.
correct.
So,
Yeah.
so now circles can be formed here. You have to be careful of which types of circles, how many circles and all can be formed. You can take cases and do it.
Hmm.
For example, there are 7 points outside. Case one is you can draw circles through them, right? Three at a time.
Yeah.
Yeah,
The circle passes through three of the points that are outside. So, and it doesn't touch any point. It doesn't pass through any point on this inside this, right?
Right.
There are 5 points here. Let's call them set A. Let's call the 7 points outside set B. So circle is through 3 points of set B. So that is possible. So you have 7 points total, and to make a circle that passes through those points, you have to do 7C3. Number of circles that pass through will be 7C3, right?
Oh,
Select any
yes.
three out of them.
yeah,
Yeah.
Then that is one case. Then another case could be circle will pass through 2 points in B and 1 point in A, right?
correct.
So selecting 2 points in B can be done in how many ways? 7C2 multiplied by selecting 1 point here can be done in 5C1.
Correct.
Then the third case
Yes.
could be 1 point here and 2 points here. Something like this. 2 points out of A and 1 points out of B. So that can be done in 7C1 into 5C2 ways.
Yeah,
And the last case is no point
Got
in
it.
this and only all 3 points are here, but there is only one circle like that.
Okay, I get it. Yeah.
There's only
Understood.
one circle which has all 3 points in here.
Correct.
Yeah.
So the idea is basically, can you make all the circles from set A, set B? Then some circles where 2 points are in set B and 1 point in set A. One circle, some circles when 1 point is in set B and 2 points are in set A. And finally, circles where all the points are in set A. So these are the 4 cases. You do this addition, you'll get the answer. And the answer is 211. However, this can also be done in a easier way than this. Easier way would be, there are 12 points total, right? So total number of possible circles should have been 12C3, right?
Yeah.
However, 5 of them are lying on one circle. So 5 of them are not really contributing to making circles, right?
Yeah.
If they were not lying on one circle, they should have made 5C3 circles, right?
Correct.
So you have to subtract those 5C3 and add 1
Yeah.
because they are contributing only one circle. 12C3 if there were no restrictions, minus 5C3 if the 5 points were contributing these 5C3 circles, but they are actually contributing just 1, so plus 1.
Yeah.
This calculation also, if you do, it comes out to be 211.
Yeah.
So both
Correct.
the ways
Correct.
you can solve it. Like there is one way where you take the cases and get it, and the other way is think of how many circles can you form from n points. That is nc3 circles can be formed. And how many are you actually getting here? Will be n 12c3 minus 5c3 plus 1.
Correct.
Okay, question 2, think about that.
We can do question 2 with the second method by saying that the 37 lines will have 37 C2 point of intersections,
Hmm.
but because the 13 lines of A and 12 lines of 11 lines of B cannot intersect. So
They are intersecting in one point.
yeah, at one point, so we can say that minus 13 C2 minus 11 C2
Hmm.
um plus 2 because two lines will intersect.
Plus 2 because they are actually contributing
Yeah,
one
one
intersection
one
point.
each. Yeah,
So normally it should have been 37C2, but 13 of them are not contributing any points of intersection except one.
yeah.
So, and 11 of them again. So, this is the answer for the second one, which will come out to be some
900 something. Yes.
535.
Yeah,
Dave, you are getting this one, second one.
Yes, I got it. Yeah. Yeah.
Okay. Uh, then next question is, in a plane, a set of 8 parallel lines, a set of 8 parallel lines intersects a set of n other parallel lines, intersects a set of n other parallel lines giving rise to giving rise to 420 parallelograms. 420 parallelograms. Many of them overlap with one another. Overlap with one another. Find the value of n. Find n. Basically, some parallel lines are intersecting with some other parallel lines. There are 8 parallel lines like this, and some other parallel lines, n parallel lines in this way. There are n of them here and 8 of them here, and it is giving rise to 420 parallelograms. So find n basically. How many parallelograms will you make? How will you make parallelograms here? To make a parallelogram, what do you have to select? Vertices, right? 4 vertices you have to select, no?
Yeah, four intersection points.
To make one parallelogram, you have to select one vertex here, one vertex here, one vertex here, one vertex here, right?
Right.
Yeah.
How does a vertex come? Vertex is coming by intersection of two lines, right?
Correct.
So
Yeah.
if I select my two lines in this direction and two lines in this direction, then I should get a parallelogram, right?
Yeah.
Select any two lines out
Correct.
of this and select any two lines out of this, you'll get one unique parallelogram.
Yes.
If I select this line and this line in this and this line and this line here, so I'll get this parallelogram then.
Correct.
So it is just simply selecting two lines out of this is 8C2, right? And selecting two lines out of this will be NC2.
Yeah. Is it? Yeah, I did this. Oh,
Oh,
I did. I did addition. Okay.
Addition will be wrong, no?
Yeah.
How
Yeah.
will addition be correct? It has to be and.
Correct. I did 8C2 plus NC2 is equal to 420, and then I was solving it.
But addition doesn't make sense, no? It's not or.
Correct. Correct. Yeah. Understood.
To make one parallelogram, you have to do both the things.
Yeah. 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 Get it.
So this product has to be 420. So now you can just solve it and n will come then.
Yeah.
N will come to be 6.
Yeah, it comes 6.
Got it.
Okay. So remember what the logic here was. You think about whatever the problem is asking, you have to think about how will that ever happen, and then try to understand how to make that selection. Then next one is, out of 18 points, no, there are p points in a plane, in a plane, no three of which are in the same straight line. No three of which are collinear except q, which are all in the same straight line, which are all in the same straight line. Now you have to find the number of straight lines and number of triangles which can be found by joining the straight lines.
Hmm.
There are q points which are collinear here out of the p points.
So will the first one be PC2 minus QC2 plus 1?
Hmm. First one is this.
I got the same.
And second one will be PC3 minus QC3.
Second one is this because this doesn't
You
contribute any
can't
triangle.
form the triangle, yeah.
This contributes at least one line.
Yeah, because there are points on Q, so they'll at least form one straight line.
Hmm. So this is how, if there are collinear points, this is how you have to handle them. You have to subtract the number of lines or point lines that they should have contributed. If they were not collinear, they would have given QC2. But now they are giving only one.
Correct.
Okay. Uh, then we'll look at this question. In 5, there is a network here. 3, 4, 5, 6. This is point A, and 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. This is point B. Ah, this is point B, and there is a network here. It is a grid. I'm not drawing it.
Hmm.
It is a grid like this. I'll draw it. Uh,
7 on each side. 7 by 7.
no, it is 7 by 7. Okay?
Oh
No,
no,
it is
6 by
6
7.
here.
6 by
6 6
7.
by
6 by
7.
7.
Yeah.
Uh, this is a network. Now, here, no diagonal movement is allowed. No diagonal movement. You can only go right and up. These are the only two steps you have, right? And you can go up. You can go like this and you can go like this. That's all. Uh, no, first thing to find out is how many paths are there from A to B. Number of paths from A to B. Then, uh, then there is a point C. 1, 2, 3 units here and 2 units down. 1, 2. There's a point C here and a point D here. Okay. So the second part of the question is how many paths from A to B? Paths from A to B go through C. Go through C. And last part is how many paths go through the CD road. Go through CD. So think of this as cities. A and B. A is your starting point, B is your destination. And
Yeah.
you have to go like this. C and D are two cities in the middle. And total number of paths in the beginning, first you have to find. How many total paths are there from A to B? Your only moves are right and up. These are the only things you can do.
So is the first one 13 factorial by 5 and 6 into 7 factorial. 6 factorial into 7 factorial.
How? Why are you saying that?
So we can say, so basically to reach from A to B we need basically 1 to 7 horizontal movements and 6 vertical movements.
Hmm.
So for that to happen, the total so basically total will be 13, sorry.
Hmm.
And each of both of them have to be done. So
Hmm.
that's why.
So then how the answer is coming? What is the idea then? Both of them have to be done fine. Then how are you getting 13 factorial by 7 factorial 6 factorial?
Mm,
The idea is correct only, but how are you getting the answer? Why did you say this? Tell me. I can't hear you. You are not saying anything right now, according to me. No, I can't hear you. You can rejoin if there is some issue with the mic. Are you getting any
Hello?
ideas? Yeah, tell me, Dave.
Hello.
Yeah,
Yeah, yeah. Now can you hear me?
yeah.
Yeah. So this basically we got it because of the arrangement. We have to arrange like it's basically arranging those 13 ways of reaching in 7 and 6 ways.
Uh-huh.
7 ways of going forward and 6 ways of moving upward. So that is why we have to do this.
Okay, when you're saying arrangement, how does arrangement matter?
Arrangement in the sense that it's basically saying that we do not follow the same path again while going, like uh basically so that we do not count the path again, the same path again.
Uh, so number of arrangements is not going to be this. Arrangements will be much more. How are you getting this number as arrangements?
Um, Sir, what I think is that maybe what we can do is we have seven paths uh, to the right and six
Mm-hmm.
paths. Wait, is it? Yeah, we have six paths in the way up. So we can choose any, we can make cases, right? Like one one to the right and then six up and then two to the right and something like that.
Two to no one to the right and six up will mean you'll end up here only.
Yeah, like okay.
You have to
Uh,
end up at B, no?
yeah, no, no. Sir, just a minute.
Yeah.
Yeah, right. Okay. Yeah. That one.
The idea is simple. You have 13 steps to take. You have to select 7 right steps and 6 up steps. You have to
Yeah,
select,
yeah.
not arrange.
Correct.
Anywhere, if you put 7, like it's a sequence of right and up, right. If you put 7 of them and then 6 ups, that is also fine. You have to just, out of 13 spots, you have to put 7 rights somewhere, and the remaining will be ups, right? Out of the 13 steps, if you put right 7 of them somewhere, then also you'll end up at the same place.
Yeah.
The remaining steps are assumed to be up, right? Suppose I take
Yeah.
first one right, then one up, then two rights, then three ups, then two rights again, then two ups, and then two rights. Then I end up at B, right? Even if I take 7 consecutive rights and then 6 consecutive ups, then also I end up at B, right? So the idea is, out of the 13 possible steps, select wherever you want to put the 7 rights. Select all the spots where you want to put the right. How many ways can you do this selection? Each selection will count as a different path, because in each selection you know the corresponding up steps where they have to come. Each selection is obviously different from each other, no?
Right.
How many places can you select the right steps? Like out of 13, select 7. So you know the selection, like it will either be 1, 2, 3, 4, 5, 6, 7, or 1 whatever, right? Different ways of selecting the 7 rights, correct? So for
Right.
each of these selections you have one path, because the corresponding up steps are already fixed. Whatever is not a right step is an up step. So that's why it will be 13 factorial by 7 factorial 6 factorial. You're not doing an arrangement here. It's not an arrangement, it's a selection of spots where to put the right. Each right is indistinguishable from another right. There cannot be any arrangements,
Yeah, got it.
right?
Yeah,
What you mean by arrangement is actually where to select the right.
correct.
That is actually a selection out of 13. Like out of 13 spots, pick the spots where you want to put the right. So you have to select 7 spots basically, or select 6 up spots. 13C6 will also give the answer. That is also correct. It's the same thing. So now, second part, how many paths from A to B go through C? You have to go through C now. You have to reach C and then go from C to B, right?
Yeah,
Go through C means A to C and C to B. So the question has
Yeah,
been broken into two parts with an AND statement. So this is multiplication rule, right?
correct, correct.
So just do the question for A to C. It is simpler. 1, 2, 3, 4. 1, 2, 3, 4. So it is a 4 up, 4 right, right?
correct.
So answer will be 8C4 ways to go from A to C. Out of the 8 steps, select 4 rights, right?
Yes, yes,
Multiplied by from C. Wait, 1 second. 1, 2, 3, 4. 1, 2, 3, 4. Correct. And from here it is 1, 2, 3, 1, 2. So there are 5 steps and you have to select
Two.
3 right steps.
Yeah,
From
three.
for going from C, 1, 2, 3. No. Okay, C is here. So 1, 2, 3, 1, 2. Yeah, 5 steps.
correct, correct.
You have to select, these are the total number of ways, right?
Yes, yes,
8C4 into 5C3 will be the answer for the next part. Correct. And how to ensure that you go through CD, right? How to ensure that you go through this road always? So again, obviously you have to come to C first, right?
Yeah,
Correct.
yeah,
So 8C4 will be same, but in order to go through this road, then you will always end up at D, right?
yeah,
So then find the number of ways to go from D to B, right?
yeah,
Which is 1, 2, 1, 2, 4C2, right?
correct.
4C2 ways to go from D to B. This ensures that since you have to come to D, you are passing through CD, right?
Yeah,
Are you seeing the difference between this and the second part? See, total number of paths were 8C4 into 5C3 here, right? So
correct.
8C4 into 5C3 was how much? Find the value here of that once. Uh, that will come out to be 8 by 4 factorial into 8 factorial by 4 factorial into 5 factorial by 3 factorial 2 factorial. So 8 into 6 into 7 into 5. So it will become 8 into 6 into 7 into 5 by 24 into 5 factorial by 5 into 4 by 2. So 10, right?
840.
So this is becoming by 4. This is becoming 2. So 700 is coming for me. 700 is the first answer.
Okay, okay.
I
Yeah,
mean, do the calculations once, see if it is right.
understood.
700, I think.
Okay, yeah, it's 700.
70 is
Understood.
8C4.
Yeah,
So this one will be 70 into 4C2 is 424 by 4, 6, right? 420.
Yeah,
So what we are getting is there are 700 paths that come out from, that go from A to C and C to B, out of which 420 are such that you pass through CD. So basically it is like A to C and then D to B,
Yeah.
right? So are you understanding this part B and part C? So
Yeah, got it.
this is important
Yeah,
because
yeah, yeah.
uh, and how to select number of paths, that should also be clear, right?
Yeah.
Okay. Uh, then we'll move on to permutations or arrangements. Arrangements. So here the first thing is if there are n distinct objects, number of permutations of n distinct objects, n distinct objects will be how much? Will be n factorial. Basically, what I'm saying is A, B, C. How many ways can you arrange it? So what are the number of permutations of this A, B, C? So you can do A, B, C, A, C, B, do B, C, A, B, A, C. You can do C, A, B, C, B, A. Right? There's no other arrangement left. Correct? These are the 6 different arrangements. No?
Yeah.
Okay. So that is the number of permutations of n objects. N objects were distinct from each other. If they were identical, then you would not be able to permute them in so many ways, right?
Yeah, yeah.
For example, if we look at a question here, uh, so question is number of words that can be formed using the letters of the word num number of words that can be formed using the letters of combine. So there are 7 letters here, and all the letters are distinct from each other, right? 7 letters, all of which are different from each other. The number of new words that can be formed is 7 factorial, right?
Yes, correct.
Correct.
Yeah.
So if suppose you had some restrictions, so words have to begin and end with a vowel, with a vowel. So you have how many vowels here? O, I, E, right? Correct.
Yeah.
So you have to begin and end with a vowel. So beginning position can be filled in 3 ways from the 3 vowels, and ending position can be filled in 2 ways then, right?
Yeah, 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 correct.
So first position can be filled in 3 and second way can be filled in 2, and remaining 5 can be arranged in any number of ways, right? 5 factorial
Yeah, yeah,
ways,
yeah.
right?
Correct.
Answer should be 3 into 2 into 5 factorial here, right? Then
Yes.
uh, you can do more complicated questions. So one more question here would be in how many of these words do the vowels and consonants occupy the same relative positions as in combine? So you have to find the total number of words where vowels and consonants occupy same relative positions as combine. So basically wherever there was a vowel in combine, you have to have a vowel here. Wherever there was a consonant, there will be a consonant. And how many words can you form like that? So at the positions of O, I
Sir, can you please repeat what this what a relative position is? There was some network issue. I couldn't hear.
think yourself, what is the relative position? Vowels and consonants occupy same relative positions as combined.
Mm, maybe uh, if a vowel is from the second place from the start, then a consonant will be from the second place from the end.
What?
Um,
Think. What is the meaning
okay.
of the statement? Vowels and consonants occupy same relative positions as combined. Same relative positions. You don't have to make up any rules. You just have to say that wherever there was a vowel in combine, it will be there only in the new word also. And wherever there was a consonant,
Okay.
there will be a consonant.
Oh, okay. Yeah, I didn't read it. I didn't read it completely. Okay, got it now.
If O was here, then you have to put a vowel here, put a vowel here, put a vowel here.
Yes, I got it. Position has combined. Just a second, sir. I guess I got this. Combined. Okay. Over. So is the answer 144?
Yeah.
Okay, yeah, got it.
Basically, in these three places, you have to put the three vowels. So that will be done in 3 factorial ways, right? And in these
Yeah,
four
and that'll be
places,
4 factorial.
that will be 4 factorial ways.
Correct.
So that will give you 144. So total number of ways of arranging the vowels in their vowel spots and consonants in their consonant spots will be 3 factorial into 4 factorial. So notice that that will be much less than this. This is 5040. But here you could change positions. Here you are fixed with the vowel positions and the consonant positions. So it is much lesser here, right? Uh, then
Correct.
number of permutations of R objects out of n distinct objects. So suppose second thing is basically number of permutations of R objects out of n distinct objects. So by permutations we mean arrangements of R objects. Arrangements, you should always think of permutation as an arrangement. So this question is basically asking how many arrangements are possible of R objects out of n possible different objects. So, so you should always think of this as if you have to arrange some R objects, first you have to select them, no? First select, then arrange, right? Correct.
Yeah.
So first of all, you have to select those R objects which you will arrange later, right? So that will be done in NCR ways, right? And once you have r distinct objects, arranging them can be done in r factorial ways.
Correct. Correct.
So the total value becomes n factorial by n minus r factorial multiplied by r factorial, which is becoming n factorial by n minus r factorial. And this quantity is sometimes written as NPR, this thing. NPR is always greater than NCR, obviously, because NPR is equal to NCR into R factorial. So
Yes,
the
correct.
idea is that this is arrangements of R things out of N things, arrangement of R things out of N different things. And that was, so arrangement can obviously be done by first selecting them and then arranging them. Right, so selections, number of selections must be smaller, right? Then only you can select and arrange will be equal to this, right? I hope this part is clear why it is coming like this.
Yes, understood.
Okay, then question is, how many different number of different four letter words that can be formed using the letters that can be formed using the letters of the word history. Hmm.
So that will be 7p4, right?
That will be 7p4, but you should think of it as 7c4 into 4 factorial because that is
Right.
easier to think about. Don't think like 7p4 you can say, but it's better to think of this, right? First select the four letters, then arrange them. I mean, that seems more normal. You understand, right?
Yeah.
Uh,
Yes, sir.
then, uh, for example, you have five distinct red balls, five distinct red balls, three distinct black balls, three distinct black balls, and two distinct white balls. Two distinct white balls, which have to be placed. They have to be placed in three distinct boxes. Three distinct boxes, such that each box contains only one ball. Such that each box contains only one ball. Okay, so how many ways can you fill the you can fill the three boxes, right? How
Just
many
let me check.
different ways can you fill the boxes?
5, 3, box.
Point to note here is that boxes are also distinct. So box 1, box 2, and box 3. And the balls are also distinct, right? So actually balls are like this: red 1, red 2, red 3, red 4, red 5, black 1, black 2, black 3, W1, W2. These are the balls. Are you understanding here that the balls are different and the boxes are different? So if I put a red, red, red here, then it matters, the order matters, right? It is like which red was here and which red was here and which red was here, it matters. If I put a different red, it is different from the other case, right? Since the balls are also labeled. Do you understand what I'm saying?
Yeah, got it.
Like R1 in box 1 and R2 in box 2 and R3 in box 3 is different from R2 in box 1 and R1 in box 2 and R3 in box 3.
So it'll be 5c3 into sorry, 5c3 into 3 factorial plus 3c3 into 3 factorial.
Why are you doing it like that? Why don't you do it 10C3 into 3 factorial?
Yeah, we can. Yeah, correct, correct.
There are 10 different balls, no?
Yeah,
It
yeah, yeah,
doesn't
yeah.
matter.
Yeah, 10 different, correct.
10C3, select the 3 balls that have to go wherever,
Yeah,
and then arrange the 3 balls in the 3 boxes in 3 factorial ways.
correct. Yeah, we can do it that way. Yeah,
The answer is simply 10P3.
yeah, got it.
Hello, Dev, are you there? Dev, are you there?
Yes, sir. Sorry, I got disconnected.
So it will be 10C3 into 3 factorial, right?
10c3 into 3 factor. Yes, correct.
Why? Because all the balls are different and all the boxes are also different. If the question was slightly different and some balls and all were identical, then the number would be much smaller, right? If all the red balls were identical, all the black balls were identical, and white balls are identical, then it would be much lower, the numbers. That would be a different question, because then you have to select based on color. You have to see that, okay, either red here or red here or red here, right? Then you have to do in multiple cases.
Yeah.
However, in this case, it is fairly simple because everything is distinct. This is distinct, so 10 balls are there. Select the 10C3 balls and then arrange them in different 3 factorial ways, right?
Yes, correct.
Okay. So then what we will be looking at is permutations when objects are not all distinct. So that is the next thing. Uh, but we'll look at it in the next class. Today's class will be slightly short. I will end it here. Next
Okay.
class onwards, what we'll be looking at is permutations of identical objects are also there. Then what to do, permutations and circular permutations we'll be looking at, and more problems with different cases. After that, the major topic that will be left is principle of uh, mutual exclusion, inclusion and exclusion, and pigeonhole principle. Maybe not a lot, so we'll see. Let me know. Maybe we can do a class on Monday or something, or
Yeah,
tomorrow or Monday.
anything's fine for me.
So just let me know what your schedule is like. Message me what the plan is for you guys, and
Yeah,
we can fix up a time. Okay.
Yeah, sure, sir.
Okay. Bye.
bye.
Yeah,
Thank you,
thank you,
sir.
sir. Bye.
Hmm.